Welcome to section 3.2, solving systems by substitution. We're going to talk about this today. I'm going to do several examples for you. Let's go to work. So we're talking about systems of equations. And remember, systems of equations is when we solve two or more equations and or inequalities simultaneously. Big word, it just means at the same time. We've already talked about the graphing method, graphing both equations and looking for the point of intersection. Today we're going to talk about the substitution method. We've already read and highlighted section 3.2, so we have a little bit of an idea for substitution. One of the things that's really cool is if you can learn all three methods, certain systems are set up to where graphing may be the best way to solve the solution system. Sometimes it's set up, and the first couple that I'm going to do are set up beautifully to use the substitution method. And in the next unit, we'll learn about when problems are set up beautifully to use the elimination method. That way, if you know all three methods, you can use the method that makes solving the system the easiest. So today we're going to talk about substitution method. So let's look at it. When doing the substitution method, if we have one equation that's already solved, like for example 1 here, this first equation's already solved. So it makes it very, very easy to do. I'm just going to take this 5 and I'm going to substitute it in for the x in the second equation. So I end up with 2 times 5 plus y equals 12. Now I just do my arithmetic. 2 times 5 is 10, plus y equals 12. Subtract 10 from both sides. Y equals 2. So now I actually have both my solutions, and my point of intersection would be 5, 2. If I had graphed both those lines, they would have intersected at 5, 2. Now you can see in that particular case, it's a very simple substitution problem. Let's do one more that's very similar to that, where it's set up beautifully for the substitution method. Here I'm going to take this 3 and I'm going to substitute it in for the y. Why? Because y equals 3. So negative 3 times x minus 7 times 3, substituted 3 in for the y, equals a negative 18. Do a little arithmetic, so negative 3x minus 21 equals a negative 18. I'm going to add 21 to both sides. So negative 3x equals 3. Divide by negative 3. And x equals a negative 1. Now, in this particular case, I am completely done because my first one was already simplified to y equals a number. In the next problem, it'll get a little bit more difficult, and we'll have to substitute this value back in. You'll see what I'm talking about in a minute. But here, my solution then is negative 1, 3. Again, that's the point of intersection if we had solved the system graphically.